I've started again on sample problem 4 by simply drawing a visual of the given information. Now, in this case, the first thing that you should notice is that the angle that was given is a non-included angle, and it is less than 90 degrees, so we're dealing with an acute angle. Now, that is going to give us some possibilities of what type of triangle or how many triangles we have based off of and depending on the length of side B. And of course that will be determined by the measure of angle B when it's all said and done. So we're going to go ahead and start this process just like we would any other law of sines problem. We're going to set up the given information and we're just going to solve for a potential first triangle. And so we'll start right there to begin with. And so you can see that angle C and side C give us a completed ratio, which will help us with this solving this proportion. And I'm going to go ahead and solve for angle A in this particular case. So if we just do our basic cross multiplication and then use our inverse function for sine, we can come up with the measure of angle A, which in this case is 57.7. And by using that information, we can come up with the measurement of angle B as well through using the internal angle theorem. So I'll go ahead and solve for measure of angle B also. And we come up with a measure of angle B of 97.3 degrees. Okay, so now that we have measure of angle B, we can go and work side B. And I'll go ahead and set that up with the previous ratio given with angle C and side C. And I'll use this same information to help me solve for side B. Okay, and now you can see here we've solved for all of the missing parts. And we have, at a minimum, one triangle as a solution. Now, because of the fact that the non-included angle was less than 90 degrees, this is a situation where we need to definitely check to see if there's a second possible solution. Okay, and so this is where we have a little bit of a new thing that we need to work here. We need to test to see what the possibilities are. So if we go back to a previous page in our notes that gives us a process for helping us find the ambiguous case, we'll see a little process here. Now, you don't really initially, you probably need to use this pretty regularly, but after a couple of chances of working with this, you probably won't need this process anymore. It'll probably just come very natural to you. So what I'm going to do is I'm going to start testing this triangle by subtracting that initial angle from 180 degrees. Then what we're going to do is we're going to take that total of 122.3 and we're going to add it to the initial angle. So the angle that was given to us in the very beginning of the problem. From here, we're going to subtract this total from 180 degrees. Now, this is the value that we're looking at. If this value is a positive value, which it is, that tells us that there's two possible triangles. And so we need to go and look for the value of that second possible triangle. And so that's one of the values for the missing parts of that second possible triangle. So that's what I'm going to do next. So in this process of testing to see if there's two possible triangles, what I've actually done is I've found the other possible angles in the triangle. So what we've got here is we knew initially that the measure of angle C was equal to 25. So what we found in this process is by subtracting the initial angle that I found for A of 57.7, I found 122.3 in this case, and what that told me was what the other possible angle A measure was. So angle A is going to be 122.3 degrees, thus leaving us for angle B the 32.7 degrees. So by testing those different angles, I found the other possible triangles here. So what this is going to allow me to do is, I was already given two sides in the original part, and now that I found two different possible angles for angle A and angle B, now I just need to find side B. So let me go ahead and do that for you. And now what we found is that the new possible length for side B is about 1.3. Now, just so that you can get a visual and understand why this works, I'm going to draw both triangles as close as I can with the possible angle measures so that you can see what these would basically look like with legitimate angle measures. Okay, so now that I'm looking at these two possible triangles side by side, let's take a look at a couple things here. Notice that angle C is 25 degrees in both triangles, and I've tried to represent that as close as I can to angle C, to 25 degrees as I can. Now, this is an important aspect of this. In both of these triangles, angle C, 25 degrees, is the smallest angle. So the opposite side, which is side C, is equal to 1. That should actually be the smallest side in both triangles. So I have that, and that works out just fine. Now in the first triangle, angle B is the largest triangle, angle B is the largest angle of 97.3. So the opposite side should be the largest side, and in this case it is at 2.3. As we switch over to the second triangle, angle A actually ends up being the largest angle, so the opposite side of 2 should be the largest side, and that works out in this case as well. So you can see how this could actually fold out to be two separate triangles here. Now, when you actually go through this process the first time of testing whether you have two triangles or not, it's not gonna make sense right away. But as we work more problems in class and we discuss it at the different ways of doing this, it'll sink in a little bit more. So with this particular type of problem, practice helps the light bulb go off. Okay, so that's a good example of having multiple solutions when using the law of sines.